This is problem number 4 from section 7.3. It says find all solutions to the equation, express the results in radians. Now the difference between this problem and some of the other ones we've done, they say find all solutions to the equation. They don't give you 0 to 360. They say they want you to find all solutions to the equation, meaning you're going to write an expression that would give you every solution from essentially 0 to infinity. So when you solve this problem, it's actually a lot easier than you would think, but your answer needs to be some expression that gives you all the possible solutions. So we're going to start this problem out. It's pretty simple to solve this. We're going to subtract the 1 over, and we get 5 tan t equals 5. Divide by 5, we get tan t equals 1. Now, we really want to know what angle here, right? We want to know what angle t will make tangent give us 1. Well, remember tangent is sine over cosine. So I'm going to write tangent as sine over cosine here. So basically, anytime I divide sine and cosine and I get 1, right? Anytime I divide sine and cosine and I get 1, that's where my solutions are going to be. So I look at the unit circle here, and I'm not going to get 1 when I divide sine by cosine here because they're not the same thing. So I need to look for things that are the same. Well, root 2 over 2 and root 2 over 2 are the same thing. So if I take root 2 over 2, and I'll just write that down. So this is for tan 45. I'd get root 2 over 2 over root 2 over 2. Well, they're the same fraction, so that just gives me 1. So 45 degrees is one of my solutions. Now I can look at the other 45 degree marks, and you can see that this one, they're close, but they're not the same. They'll give you -1. This one over here, or this one down here, these are the exact same, right? Negative root 2 over 2 and negative root 2 over 2. So this gives you 1. So quadrants 1 and quadrants 3 for the 45 degree angle spot, those two areas are going to give you tangent as 1. The other two areas give you tangent as a -1. So the only ones that work are quadrants 1 and 3. How can I write this to say that this angle and this angle are my solutions no matter how many times that I circle the equation? Well, I can write this two ways. So I can say 45 degrees plus, how many degrees would it be from 45 to 225? Well, that's 180 degrees, right? That's just halfway around the circle. So I'm going to say plus 180 degrees, but I don't want to just say it once. I want to say it n times, right? Because if let's just say n is 0, right? Then I would have just the 45 degree mark. If n is 2, now I get both the solutions. If n is 3, I get 3 of them, so on and so forth. It'll just keep going around coterminally and give me all the possible solutions. Now that's if we're in degrees. What if we're in radians? Well, for in radians, 45 degrees is pi over 4. And 180 degrees is pi in radians. So we just replace the 45 degrees with what its angle is in radians, and replace 180 degrees with what its angle is in radians. And that would be our solution for this problem, because they do ask for it in radians. So overall, that problem is not that difficult, especially if you just look at it in degrees and convert it to the radians.